and welcome back. In the last lecture we talked about indexing in the Python array, and so for this lecture we're going to check the runtime when performing operations using the in the array versus when using the regular Python list. So to do this we need to import a library to check the runtime, and the library name is Timeit, so we import the library Timeit. And let me initiate the first variable, so I'm going to call it Python native time. So this is my first variable here, so it will be holding the value that will be returned by the function or the method Timeit that is available under the Timeit library. So Timeit, and then in here I'll pass the operation for which I want to calculate the runtime. So sum of x squares for all the numbers x in the range of 1000, so 0 to 1000, so range 1000. And then let's close the paren and close the code, then comma, and then I'm going to close the other paren. Here I need to initiate a variable number, and its value will be 10,000. And next I'm going to print the runtime for this operation. So print Python native time. So this way I can calculate how much time it takes to run this basic operation. Let's save and run. Here we go. I need to compare that with the variable that I'm going to call npTime, and it will be holding the value that will be returned by the method Timeit of the Timeit library. So Timeit.Timeit again, and then this time the syntax will be a bit different. As you can see, when you use a method inside the Python IDE, it will give you some additional information. So the Timeit module is often used to measure the execution time of small code snippets. So the module has many functions, as I said. One of them is Timeit. So let's get back to our Python script in here, and let's use this function or this module. So na dot passing in na, and then to set up import numpy as np, and then na will be equals to np dot arrange, and then range is 1000 as in the previous example. So in the next line I'm going to print the following expression. So normal Python and then the time in seconds. So let's put a placeholder here, and so the time in seconds. Let's close the codes, and then dot format, and the format of Python native time, Python native time, and in the next line we can print the following expressions. So open paren, open quotes, and then numpy, and then the placeholder times in seconds, and then dot format of np time. Let's close the parens and save and run the code. Here we go. So for Python native time, it takes 7.14 seconds, while using NumPy it took only 0.037 seconds. So it's like 70 times faster. So now you know the difference in terms of runtime. Next we're going to explore the data types, and so unfortunately for the sake of speed we made some sacrifices. Data arrays don't have the types flexibility that the lists have, and so let me add a few lines of code here. So a np.array, actually let me just start a clean file. We'll initiate the variable a that will be holding the output of the method array, passing in the list 1 2 3. So 1 comma 2 comma 3, close the brackets, close the paren, and then let's call a dot d type, and let me print this out. So print and close the paren, run the code. Of course I need to save it. Of course I need to import numpy as np, so import numpy as np, save and run. Here we go. So it says int32. Now let's do np.array, and we're going to pass an array that is 1 comma some text comma set, and we're going to pass a set here of 1 comma 2 comma 3. Close the brackets, close the first paren, close the other bracket, and finally close the paren here, and let's call the print function now, passing in this expression. So print, let me remove the print function here and assign all this expression to a variable. I'm going to call it b, and now what I can do is print b dot d type. So let's try this, and let me save and run. And so here it says object. This is considered an object, so it has no type attribute. Next we're going to talk about Scipy and matplotlib. So Scipy is a package containing fundamental algorithms for scientific computing in Python. It's a fantastic tool along with NumPy, as it's built on top of it, and it is a great building block for machine learning packages and algorithms. Scipy has lots of useful sub-packages like IO, stats, optimize, and others. Matplotlib is a Python library for data visualization and plotting data into a figure. It's very handy and helps you see the data and watch how they change or interact. And it is used along with NumPy and Scipy to provide you with the full experience you require. Make sure you have them on your machine using pip install scipy matplotlib or conda install scipy matplotlib. So let me open up the command line here, and so here I'm going to install Scipy. So I'm going to call the pip command, so pip install scipy matplotlib. So matplotlib, and let me run this command. Wait for it to download and install. There we go. Once it's downloaded and installed, we can use it for the next few tutorials.